we're all ready, so let's go ahead and go with this. So, class.
Yes.
Bruh. Okay. Anyway, all right, so I'm going to go through, making sure this works. Investigating a infinite limit. So infinite means it's going to go on forever somewhere. Now, this limit as x approaches 3 from the right. They frown upon teachers doing math. So next best thing is either 5 hours or like 19 monsters. So, right here. Let's see. As it is approaching from the left, can I plug in just 3? Say no. I cannot plug in 3 because what's going to happen? 0 in the denominator, right? So, investigate the limit. So, right here, because of this, it is going to go, let's see, 2x plus 1 and x minus 3. So I could do it a couple different ways. I could start looking at it like, oh, can I start evaluating what it would be to see what it would look like here? Can I plug in a number to the right? Yeah, I can plug in 4 because, even if you don't have a calculator, you can plug in 4 pretty easy. So plug in 4, that's 8, 9 over 1. Okay, so I know from there I can do another one to actually see where it's going to go from there. So if I plug in 5, 10, 11, that would be 11 over 2, which is 5.5. So as it is going, as it is going right now, the closer I get to 3, what do you think is happening? Is it going up or is it going down? It's going up, right? So because I'm looking at it, just evaluating what's happening. So right here, it's going that way. But as I get closer here, we can actually see, hey, that's going to be my asymptote there. That's going to be my asymptote because it's going to be an undefined, because it is growing in this way exponentially as it's going closer and closer to 3. Now, let's go ahead and look to see what this is going to be. So I could say that this, going from the right, should be going up to positive infinity. And my calculator is, I don't know. I normally have this book in my toolbar, but I'm not a smart man. So, just by evaluating at numbers next to it in consecutive order, I could see that there is a progression here as it is approaching 3 from the right-hand side. Because I plugged in 4, I found out my number is 9. I plugged in 5, my answer is, what was it, 5.5? 5.5. So I know it's going to be going down like this. Now, what else can I also figure out about this? Does this problem have a horizontal asymptote? No.
Yeah.
Okay, this is going to have a horizontal asymptote. Where's the horizontal asymptote going to be? Out at 2, right? Now, why do I know it has a horizontal asymptote at 2? Just because I can make it up as I go? Bam, right there. So he said leading coefficients. Leading coefficients right here, same degree, right? So if it's the same degree, this is going to be 2 over 1. Same degree, leading coefficients, I have a horizontal asymptote right here at 2 over 1, which is 2. That's great to know. Okay? Also, with that same degree, if the top is a degree more, 1 degree more, that's where you get your slant asymptote. Okay? You get it at a line. It's basically you divide the numerator by the denominator, and that division is going to give you the equation of the slant asymptote. Also, you guys recall what would, if the bottom is bigger, the bottom has a larger degree, what would it be? It's going to go to 0. Because as we're racing to infinity, the bottom, if the degree, so if it's a square on bottom, it's going to race faster to infinity than the top. Does that make sense? Yeah? Okay, good. So a little bit of algebra to go back with that too. So if you forgot about those things, make sure you put those in somewhere. All right, now can I plug this in? So at 1, for this next one, it's going to be 1 squared, which is just going to be 1. But ln1, can I have ln1? What is ln1? It's going to be 0. Okay, so can I have that there? No, I cannot have that there. So I need numbers. So in the restriction of my domain, Ln has a normal restriction. So I can't have anything, it doesn't exist at 0 or to the left. There's no negative numbers. So it doesn't exist over there, right? So what this is asking for, because of this right here, I'm looking at a very small window between 0 and 1. So in between 0 and 1, because this is a restriction on my domain, it doesn't exist to the left of 0, and it's asking as this is approaching 1 from the right-hand side. But if it's approaching 1 from the right-hand side, that would give me 0 in the denominator. Approaching 1 on the left-hand side, that's also 0 in the denominator. So I'm only looking at this little bit right here. So I like fractions, I really do. I really do. So if I were to do some fractions in this, so let's say 1/2. Is that in my domain that I could do? So that would be a 1/2 squared over ln of 1 over 2. Anyone recall the rules for those? If it's a fraction inside, what can I do with it? Can I separate the fractions? Yes.
ln1 minus ln2.
ln1 minus ln2. So on top I get 1 over 4 over ln1 minus ln2. Okay, ln1 is 0. So I end up with a negative ln2. Did you grab the notes?
Yeah.
Okay. So this is going to be a 1/4 times right here. That's going to be a 1 over negative ln of 2. So that means that I'm going to end up with negative numbers, right? Yes? So negative numbers in there. So that means that right here, as it's approaching, I need to understand, all right, it's a negative number, so it's going to, looks like it's going to go down, right? Now let's find another number that's closer to this number. So another number would be like 3/4, right? 3/4, would that be, that would be closer to my 1, new color. So that would be 3/4 squared ln of 3/4. This one's not as easy, but right here, I'm still going to end up with a negative here. So this is going to be 9/16 times the reciprocal of this, which is 1/ln of 3 minus ln of 4. There you go, like that. Now, which one's bigger, ln3, ln4? ln4, right? ln4 is going to be bigger, so that means that all of this is going to be multiplied by a small negative number, right? So, right here, I'm looking at these two to compare. They're both going to be negative, aren't they? Because I'm trying to imagine what the graph is going to look like. So, as I'm getting closer, is it going to be a bigger number or a smaller number than this? This is going to be a bigger number, right? So this is going to be a bigger negative number. You're looking at me crazy. Why are you looking at me crazy? No?
No,
Okay. So this one right here is going to be a bigger number than that one over there. Why do I know that's going to end up being a bigger number? Is there something that I could pick out that might actually help me with this? How about that top? The top is just 1 times 1, right? So it's going to be 1. So it's going to be smaller, and then this is going to be like a, I don't know, that's like a 16th or something like that. And this is 9 times 1 times, that's, even if it is about the same, the 16th. Wait, yeah. So either way, this is, as I get closer to my 1, it should be going down more, a bigger negative. So I'm trying to imagine what that's going to be. Okay, so doc B. And control, divide, x squared over ln of x, right? That's it? Okay. Here we go. So from right here, I could see as it's approaching 1 from the left-hand side, it's going down. So I don't need the calculator to tell me every single time, because like I was saying, for those people that walk in late, the first 2 tests, I know the first test is definitely no calculator, but I think it's the first 2 tests that are no calculator, because it's too easy. Just plug this in to actually see, oh hey, it's right there. You're going to have to know how to do the steps to actually get there. And what steps did I use to get here on this problem? Evaluating at numbers approaching that. So I'm just getting closer and closer to that number. This one was easier because I could use integers. This one I have to use rational numbers. I'm using fractions for this. But yes, it might take you a little bit more math on these ones, but life goes on, right? Okay. All right, find any vertical asymptotes graph of this. Now, vertical asymptotes means what? What do I have? Up and down, right? Okay. But what would that tell me? Okay, how would I get one of those? Undefined, right? Yeah. 0 in the denominator, right? So 0 in the denominator. So that's what I need to focus on. So whenever I'm doing these type of problems, I need to look, oh, okay, 0 in the denominator is going to be my problem child here. So what I'm going to do, I'm going to take this. This is going to turn into x minus 3 times x minus 3 equals 0. And what does that tell me? Okay, I have something at 3. So you're saying x cannot equal 3. Is there going to be another one? What about horizontal asymptote? We just said this a moment ago. Horizontal asymptote. The degree of the bottom is greater, so therefore it's going to go 0. It's going to have a horizontal asymptote at 0 for these. All right, let's see. The graph. Go back to my calculator. Okay, doc B. And control divide x over x minus 3 close squared. There we go. Now I can see where my horizontal asymptote is right there. Okay, it's approaching there. Right here, that's going to be 2, 3. It does not exist at 3. And I could actually test it to make sure that, okay, it's not just some weird, wonky, graph that goes up. So if I had my calculator, I can go menu, analyze graph, and trace graph. There we go. All right. So bring it up. What happens at 3? There you go. Get a nice define. So dotted line. Make sense? Nonsense? A little bit of sense? No sense? Okay. All right. Investigating the limits at infinity. If k is a real number and n is greater than 2 is an integer, and the function f and g approach real numbers, so as x approaches infinity, then the following properties are going to be true. Limit of a as x approaches infinity, so this is a constant. There's no variable there. Okay? It's just going to be a. This is what it's always been for all the limits. If it's a constant, there's no variable, it's not going to vary. It is going to be that number. Limit as x goes to infinity, k times my function. It just turns into k times whatever. So you could factor out the k of the function to be in front of the limit. That's important. If there's plus or minus, I could actually separate it. We had this issue yesterday, homework problem. You can separate it into different individual parts, just so we could actually use that. And same thing goes here. So n, this is the n for my exponent. So limit raised to the power, it's the same thing. So if you notice, I could actually do the power at the end, but find the limit first with the brackets, the same as parentheses, that's what that means. And same thing goes. So power rules and root rules are the same, because a power is a root. A root is a power. Okay, so it's just raising it to a fractional exponent. Limits at infinity. Now, as this is going to negative infinity, what do you think that one's going to be? So as x approaches infinity on the left, what's going to happen? It's going to go to 0. He says 0. Anyone else say anything? Yeah, we're still doing that one.
Yeah.
You want to chime in?
No, I don't.
You don't. Why? Because you're really behind. You don't know what we're talking about?
That's not true.
No, I'm asking.
No, I just don't want
You don't want to? Are you okay with what I'm doing, or I'm not making any sense at all?
to. No, you're making sense.
Okay.
I just want to see more.
Okay, I'm just making sure.
Yeah,
Can I check on people?
okay.
Okay. So you're saying that this is, as this goes to the left of a number line, numbers get bigger, negative, right? This one's still going to be 4 divided by negative infinity. Yeah, it's still going to give me 0, right? No matter how far I go to the left, it's still going to go at 0. Now, this one right here, as it's going to positive infinity. As it's going positive infinity. So, what do you think that's going to happen? Is that going, so this is going to the right. So, my infinity is in the denominator, right? So, is this number going to keep getting larger? Yes, it is. That's going to keep getting larger, so that's important to understand. If the bottom keeps getting larger than the top, that means I'm dividing it by more and more things. Okay? It's like having, let's say we have 6 people in this room right now, okay? I go get 6 pizzas. That division's pretty easy, right? How much pizza does each person get? 1, right? Okay, but now I'm dividing it by a larger and larger number. Okay, bring in another group. We have 12 people, but I still only have those 6 pizzas. So what's happening to the amount of pizza everyone's getting? It's going smaller, right? Okay, so now I'm going to add another big chunk of people. I'm at 24 people now. Those 6 pizza now turns into a quarter. I'm going to keep adding and adding people that I'm dividing my 6 pizzas by. And so at some point, everyone's just going to get a sniff. That's it. Okay? There's nothing going to be left. Make sense? Okay, good. So this one's actually going to 0 again. Now this one right here, what do you think this one's going to? Infinity? Okay, so right here, if I break up this limit, is this a constant? So limit as x approaches infinity of the number 2 plus limit as x approaches infinity 3 over x. This first one here is a constant, right? So what do you think the limit of this one's going to be? 2, right? That's 2 plus, right here, 3 divided by infinity is, count 1, 0, right? So by looking at it in 2 separate parts right here, it's going to be the limit here is 2, the limit here is 0. My limit for the whole thing would be 2. Is that sense or nonsense? Are we good so far? Not too crazy, right? Okay. But tell me if it does get kind of crazy though. I like this one. Who is racing to the top faster? 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 right here. Okay, who's racing faster? So is it the top or the bottom going to be racing? So what this is going to look like is 3 times infinity squared and the bottom is infinity squared. Why am I not including the rest of it? Isn't infinity squared plus 1? What's that going to be? That's just infinity, right? And then because this is infinity squared, does 2 times infinity matter? No. Does the plus 8 to infinity, does that matter? So in these problems right here, what's the only thing that matters? The leading terms. The leading terms are the only pieces that are going to matter here. So that's the reason why this is going to matter. So I have infinity squared over infinity squared here, right? So what do you think this is going to race to? It's going to go to 3. That's why I brought up about the horizontal asymptotes before. Is this same rule applies to infinity, that it's going to end up going to just 3. Because no matter how large infinity is, it is still infinity squared over infinity squared, and that's 3 times infinity. So that coefficient and this coefficient are the only ones that matter. What about B? Why 0? The degree of the bottom is 1 bigger, right? The degree of the bottom is 1 bigger, so I'm looking at that. So racing to infinity faster. If the degree of the bottom is bigger, then it's going to go to infinity faster. That means that it is 4 times infinity squared, and it's going to be infinity cubed. Again, with the pizza analogy, I'm going to keep dividing this number by larger and larger pieces right here, right? So I still have this here, but I'm dividing it by larger and larger. So that means that this is going to race faster than the numerator. So therefore, this is just going to go to 0. Or if I care about the negative in here, would that be a negative 0? Because that would be a negative infinity and a negative infinity. Is that going to matter? No. All right, is that the one for today? Oh, last one here. Now, what did I say is the only thing that matters? The coefficients, right? So if I say the only thing that matters is the coefficients, that means I'm only looking at this. So in this problem right here, as I'm racing to infinity, the rest of it, blah, blah, blah. So what is this one going to be? Since this is in a square root, this is going to be 2x over the bottom, which is x. So racing to infinity now, do they have the same degree? Now, by rewriting it and looking at this and only looking at that piece right there, they're going to race to infinity at the same speed. So therefore, I just look at the coefficients in front. So this one is going to give me 2. Is that the last slide? Or is there a whole bunch more?
There's 7 more.
7 more, okay. Just making sure. Because the next one is right this. I am stopping here on these ones. And then I'm going to pick up the rest of these tomorrow. Everyone here is going to like, share, and subscribe. Hit that notification button, especially if you walked in late. And there is a discount on the hoodies on my store. So make sure you buy my merch.